All right, so we are on lesson 1-2, day 1, which is using the straight edge and compass to construct basic construction figures. First thing we're going to do is we're going to go over this. This is from the vocabulary sheet. We will be adding on to the vocabulary sheet today as well. Okay, so just keep those out. But check these out because these are typical, typical symbols that you will see throughout geometry this year. Okay, it doesn't matter if you're in this class or in regular, you will see it. Okay. Okay, any questions on this? Are we good? Okay. Let's move on then. All right, so we're just going to look at the first construction. Okay, so it says, how are straight edge and compass used to make basic constructions? Before we get into that, actually, I should move this up here. I want you guys to copy down these 3 definitions. They work for angles and they work for segments. You're going to be using these in your proofwriting, so I want you to add this to your vocabulary sheets. All right, this is all from 1-2. So we have the reflexive property. The reflexive property of congruence states that if we have segment AB, it can be congruent to itself. And the same thing can work for angles. Angle A is congruent to angle A. Okay, so we can have parts that are congruent to themselves to identify if triangles are congruent or not. We also have the symmetric property, which states that if you have AB is congruent to CD, then CD is congruent to AB. You can flip-flop it. And the same thing works for angles. If angle A is congruent to angle B, then angle B is congruent to angle A. Now with proofwriting, once we get there, you have to end your proof with what they asked you to prove. So if they want you to state that angle B is congruent to angle A, but you end it with angle A is congruent to angle B, it will be incorrect. You have to use that symmetric property to do the flip-flop. And then we also have the transitive property of congruence. So that's basically stating that segment AB is congruent to segment CD, and if segment CD is congruent to EF, then segment AB has to be congruent to EF. And the same thing with the angles. If angle A is congruent to B and angle B is congruent to C, then angle A is congruent to C as well. We probably saw something similar to this in algebra. Okay, and it could have looked something like this. It might spark a memory, might not. They would state that, okay, oh my gosh, why does it keep doing this to me? If you have A is congruent, or A is equal to B, and B is equal to C, then by definition, A has to equal C. So that's the algebra way for the transitive property. You don't have to copy down anything I wrote down in red. It's just to make a connection. I need the top 3, though. You guys got to have those. Show of hands who's still writing this down. Okay, about another minute. Okay, we're going to move on to in about 3 seconds. If you miss it, remember you can always go back to the video and get it. I might actually post these slides too because it has the other videos with embedded in it too. So there's that. All right, so here is our first concept for constructions. So this is straight from the book, but I have a video for you guys to watch too. Okay. So it says the segments that have the same length are congruent segments. So what they're saying here is that's what we're going to do today. We're going to like copy things in order to make sure that they're congruent using that compass and that straight edge. Okay. And then the same thing works with angles. So that's where these reflexive and symmetric properties come from. But again, you're going to be seeing these a little later. So here's our first example. We're going to copy a segment. So it says a straight edge is a tool for drawing straight lines and a compass is a tool for drawing arcs and circles, different sizes, and can be used to copy lengths. So in this case, they're saying to copy AB, first use a straight edge to draw the line L and mark the point M on line L. You guys have a compass in front of you. A compass right here, this point right here, is called the needle. This is the pencil. What you would do is you would take the needle and put it on A. You would extend it to B, and then you would go to M and mark that as well. So after you draw this line segment, you're going to copy it by basically getting that length and then copying it onto the ray that you drew or the line that you drew. Okay. So step 3 for this is just to draw an arc to make sure it measures the same way. Okay. So it says a construction is a geometric figure made with only a straight edge and a compass. So think what you're doing today is the OG of a Xerox copy machine. Okay. That's your goal right now. So what we're going to do is for try it 1, I have a video here that's going to explain this. Someone is, it's a really good video. So in this video, the goal is going to be to use a compass and straight edge to copy line segment 8. So the first thing you want to do is we're going to use a straight edge to construct a reference line such that the reference line is definitely longer than line segment 8. It's fairly obvious that this line that we built right here, or this ray that we built, is longer than line segment 8. So we can, at this step, just label this endpoint. Okay, I want you guys to draw a point and that line. Do it right now. You have like 30 seconds. Call it point C. You can call it whatever you want. So now what we're going to do next is we're going to set our compass on the endpoint A. Are we going to extend the... Hold on. Sorry, don't know what happened there. That's weird. That should not have happened. Sorry about that, guys. Here we go. I'll fast forward it. To extend the length of the compass so that the pencil end reaches point B.
at this stage, we've set the length of the compass.
All right, do that now.
And to
I don't
verify,
know why it's going to pause. There,
we're going to set an arc, and we can observe that this arc.
there we go. Now I got it to pause. Okay, so take your compass on the original line. Put your needle at, what do you guys have? I think you guys have like what, point G or something like that. Okay, and extend. You have X and Y, right? Okay, extend it. Put the needle on X. Extend it all the way to Y. Draw a little arc to make sure you have actually intersected Y. All right. And now you're going to keep that measure, and I want you to put it on the point that you made on that ray, and then wait for further instructions from the video.
Intersects. So now what we're going to do next, we're going to set the fixed end of the compass on point C. We could do it, we're going to label this intersection point, we'll call it point D. Now, since the length of the compass was set to be equal to the length of line segment AB, we can conclude that line segment AB is congruent to line segment CD.
Okay, I'm going to stop it there. So that's how you construct a line. First, draw a line, put a point at the end of it because you're drawing a segment. Take your needle, put it on the original copy, stretch it to the point of the other copy, draw an arc just to make sure you actually hit that point. Keep that measure, put the needle back here, and then draw another arc, and you just made a copy of a line segment. Okay? Any questions? All right, we're going to move on to the next one, which is copying an angle. All right, so again, these are the steps from the book. So the first thing you're going to do is, just like before, you're going to draw that ray or that line. Okay? And you're going to label it with a point. In this case, they labeled it point X. You place the needle on the vertex of the angle. You draw an arc that you don't have to draw the arc all the way through, but it has to intersect both the rays for the original angle. Okay? You keep that measure and you bring your needle to your new copy, and you have to swing this arc past that vertex X. All right? This is not big enough. You got to make it bigger. Trust me when I say that. All right? From there, you will measure between those two arcs that you did, where those 2 points of intersection are at. You keep that measure, bring it to your copy, put the needle on the first intersection, and then swing the arc where the arcs intersect. And if you need to confirm that you did this, you can use the protractor to confirm. So let's go to the video and go through this step by step.
This video, the goal is to use a straight edge compass to copy an angle. So the first thing we're going to do to copy this angle is we're going to use the straight edge to construct a reference. And what we could do is we're going to label the end point of our reference line. We'll call this point G.
Do that.
You know what?
Draw your reference line. Give the point a name. It doesn't have to be G, but it's got to be something. Because I think, don't you guys have G on here? Or is it B? Okay, that's even better then this will work. Oh, this is going to work out like gangbusters. I didn't even realize. Okay, now looking at what you have on your sheet, is this copy going to be exactly the same as your copy? No. Okay, because you are working with an obtuse angle in your book. This is acute. Okay, so now that we have that, let's move on to the next step.
Well, I call this a reference line technically. This is to be a ray because the other end extends onto it as indicated by this arrow. So technically, we call this ray G. So what we want to do next is we're going to take the compass, we're going to fix it on vertex. And now what we do next is we're going to extend the length of this compass to any length. All we need to be sure is when we draw our two arcs, that those arcs intersect both grades of angle B. So we sketch the first arc, and we know that it intersects this ray of angle B. And now we sketch a second arc, and notice that it intersects the second ray. So what we want to do now is we're going to...
Okay, so he's telling you, just like the book did, and just like I did, put your needle at point B, and you don't have to draw two separate arcs. Just draw one single arc if you want. It's actually a lot easier if you just kind of go all the way around. Okay, just make sure it's intersecting at those two spots, and it doesn't. Just make it comfortable for you. Something that's easier to draw, like probably a little bigger the better. Just make sure it's hitting the two rays. Okay. All right, everybody still doing that? Okay, do not adjust the measure of your compass after that. Okay, you want to keep that measure for this next part.
label these two. Call the first intersection point A. We'll call the second intersection point C. So now what we want to do next is we're going to take the compass and we're going to place it on the endpoint G. And we're going to keep the length of the compass the same. And we're going to spring an arc in such a way that it intersects ray G. And we're also going to extend it up towards this direction here. So what we want to do next now?
Okay, because you guys are working with obtuse angles, see how he kind of stopped here because this is acute. You need to extend it past. You need to keep going. Believe me when I say that. Keep going. Okay. Keep going. Otherwise, they won't intersect, and you're gonna have a problem on your hands. Yes. Yeah, that's right. Switch. Yeah. Once the lead breaks, are no good. Huh? Yeah. Just use that one. How we doing? Any questions so far? You guys extended it all the way, making sure. All right. All right. So now that we've done that arc, here's your next step.
Is we're going to set the length of the compass equal to what would be line segment AC. And to do so, we're going to set the first end of the compass on point A, and we're going to set the pencil end of the compass on point C. We just want to make sure that we're precise.
Okay. So what's happening here is if you look, you see that the needle is on one point and the pencil is on the other point, and you adjust your compass so that it's hitting both of those points. Okay. This is very important that it looks this way. Okay. After that, I want you to put your needle on G and just wait for further instructions.
Now that this length is equal to line segment AC, we're going to transfer it down here. And we're going to set it on, well, first we'll call this point F. We're going to set the compass on point F.
All right, so put Put your compass on F. I know I said G, but that was just to kind of keep it out of the way. Okay. And then what you're going to do is you're going to swing an arc that will help create the X. So make sure you're on the correct angle when you do this. You don't want to go the same direction as this arc. You want it to kind of go the opposite direction. Okay.
So that arc intersects the original arc we drew down here. So we have a new intersection point now.
So draw that arc so that this way you have that intersection point. All right, how we doing? Questions? Okay, from here, you're just gonna draw the two. You're gonna draw the line for the intersection.
Label this intersection point, point D. So now the last thing we need to do is we're going to construct another array that also has point G, such that array GD. We want this ray to pass through point G. So using a straight edge, we're going to construct this second ray so that it passes through point D. And now at this point here, we're finished with this construction, and we can conclude that angle B is congruent to angle G.
All right, there it is. Okay. Oops. Okay.
Okay, well, this is going to.
So, questions on this before we move on to the next thing? Okay. All right, here is the next thing you need to write down in your books. All right, so it says a perpendicular bisector of a segment is a line or ray that is perpendicular to the segment and divides the segment into two congruent segments. You need this part. This part you don't need, but you need this part, okay? Because you're going to need that for your proofwriting. Bless you. All right, show hands who's still writing this down. Okay. Give you about another 30 seconds because it should only be like the this little area right here. You don't need the bottom, just this part. Okie dokie. So looking at this next example. So we're talking about now constructing a perpendicular bisector of a segment. So if you're now, one thing that's nice about this is that there's no copying. You actually use the segment. Okay. So you're going to have segment AB, and you are going to set your compass in such a way that it is above the halfway point, but not off the segment. Okay. With that setting, you will draw an arc. Again, you can draw the arc straight through. You do not need to draw just two separate arcs. I would just do it straight through, to be honest. Step 2 is just keeping that measurement. Don't adjust your compass. Put it on the other point, which is B in this case, and then swing another arc so you get this X, like an X on the top, or this cross, or these points in space. Okay. You can label it DF if you want. This is the middle one is actually the most important. I'm just going to let me just label that like C, just so that we're all on the same page here. Okay. What this is saying is that after we do this, this would be congruent to this, but then we'd also have everything would be perpendicular to each other. Okay. So that's what you're constructing here. This one is actually one of my favorites because it's really easy. Okay, ready? All right, here's your try. Okay.
Of line segment. So the first thing we want to do is we're going to set our compass on point A. And we're going to make sure that we set the length of the compass to a length that is greater than half the length of line segment AB.
All right, so do that first. Do that first. You can extend it however you're comfortable. Just make sure it lands above the halfway point, doesn't go off of this, and probably doesn't touch this. All right, it should be like somewhere like probably around here. Okay, so set your length. Okay, and then just keep it there, and then you're just gonna swing your arcs straight up and down.
So at this length, we can ensure that this length is greater than half the length of length. So now what we want to do is we're going to swing an arc. And we'll swing the arc, we'll make it big enough so that it's roughly a semicircle. So what we're going to do next is we're going to move the compass.
Okay, so we do this. Keep your compass with that same measure. You don't need to adjust anything. Put it on B, or whatever your second point is, and then do the same thing.
The point B, we're going to do the same thing. We're going to keep the length of the compass exactly the same. It's crucial that you do not change the length of the compass for this step. So what we're going to do now is we're going to swing another semicircle in such a way that the new semicircle intersects the original one twice. So we'll note here that these two arcs intersected in two locations. So we're going to label these points of intersection C and D. So we'll call the first point we'll call C. We'll call the second point of intersection D. So now next what we need to do is we're going to construct a line.
I hit pause and it just keeps going. All right, so we have C, we have D, or whatever you labeled them. What do you think is going to happen next now? What has happened whenever we made these points in space? We always did something with it. What do we do? Anybody? What are we going to do with C and D? Yep. Yeah, connect the line between the two. And then that pretty much ends it, guys.
And that passes through both points C and D. So starting here, and if you're doing this at home, you're going to use a straight edge. We're going to connect these 2 points of intersection. Make sure that passes through a little bit more. That's good. Now we know that line CD get arrows so that we know that this line will go on forever in either direction. But we can say that line CD is the perpendicular bisector of line segment A. The next what we want to do is we're just going to label this intersection point here. We'll call it E. So now by definition of the perpendicular bisector, we can say that angle CEB measures 90 degrees. So we can put our symbol here for 90 degrees. And also, the measure of angle AEC is also 90 degrees. And then finally, the last thing we can say, since line CD is the perpendicular bisector of line segment AB, we can say that line segment AE is congruent to line segment EB. Okay, well, this is going to conclude this video.
All right, so that's how we do a perpendicular bisector of a segment, okay? We cannot do a perpendicular bisector of a line. We can make a line perpendicular. We can make lines perpendicular, but we cannot bisect a line. Who can remind me why? What's the problem with bisecting a line and not a line segment? Lines go on for what? Forever. So can you actually find a midpoint or a center of that line? Technically, no. Okay? So just keep that in mind. All right, so for this next part, I want you to write this down. An angle bisector is a ray that divides an angle into 2 congruent angles. Again, necessary for your proof writing that will be coming up. What we will do after this is we'll do one more construction, and then that will end the day, okay? And while I have you guys writing that down, your homework for tonight is on Realize, and it's going through the steps of how to construct this stuff, okay? So I want you guys to get those steps, and then as our warm-up tomorrow, we're going to do a few more with the compass, okay? So we might not have a Google form tomorrow, but that's okay. All right, let's take a look at our next construction. So an angle bisector is to break this into 2 congruent parts. So your first goal is, again, just like before, you're going to put your needle on the vertex and you're going to swing an arc that's a comfortable length. It does not need, there's no specific measurement, okay? After you intersect that arc, you keep the measure and then you go to that first intersection, draw an arc, and then go to the second intersection and draw that same arc to find the center of the angle. After that, you connect the vertex with that center, giving you that bisector, okay? Here's just, again, something to keep in mind. Be sure to set the compass greater than half the distance from A to C, because it'll probably make your life a lot easier. We don't want anything too small where it's too hard to move that compass, all right? So here is how we're going to bisect angle G, okay?
I'm Ben, and today I want to show how to bisect an angle. So we want to bisect angle B. And what I'm going to do is I'm going to place the compass on this vertex here. And I'm going to open the compass up and swing an arc so that it hits one of the rays here. And I'm not changing the length of the compass at all for this part. The second part. And notice that I intersected the angle at 2 locations here. So we have.
All right, so in this case, if you look, you can just swing one arc and then label the points, okay? You label them what you wish. I know you're working with angle G. You can do whatever you wish, okay?
call this point A. And what I want to do is I want to place the compass point A. And what I need to
Now notice that he's putting the compass on the first point, but he did not change the measure between AB or AC. He's keeping that measure, okay?
let it go. Just because the bisector of an angle is a line. So when I do split parts from C, it needs to go to about the halfway point of the angle intersect. And now this point here, label this, but all I have to do now to keep this construction is connect point B to this intersection. And here we have it. If I do this point here, let's call this point B. I can conclude here that angle ABD is congruent to angle CBD. We'll just throw our symbol in here. So
The symbol they use is just two arcs.
angles here.
Okay? So that's how you bisect an angle. Any questions? Now, again, we're doing kind of things both ways. On your homework, you are going to be given the steps. You guys got to locate the steps. Okay? Make sure you look at things appropriately because everything's going to be could be different letters for points. On your quiz, though, we're going to give you a compass and you're going to be constructing it. So tomorrow during the warm-up, we're going to do a few more of these. Okay? Not a lot, but a few. But I think it's more important for you guys to get the steps first and then construct it again a little later. All right? Sound good? Any questions? All right. We're not doing example 5, so we're good for the day. Remember, if you didn't finish your Google form, I would highly recommend doing that. Those of you watching at home, have a great day.